Last few questions for your exam review. See me if you have any questions. State the component form. Don't forget what that means. That means it's going to look like this. And if vector A has initial point, that's definitely assigning that x1, y1. Terminal point, x2, y2. And this matters. A lot of formulas, like the distance formula or midpoint formula, doesn't matter which one you assign x1, y1 or slope. In this case, it matters. And remember the formula, x2 minus x1, y2 minus y1. So, as long as we don't screw up putting these in, 3 minus a negative 1, easy to make a mistake there. And then y sub 2 minus y sub 1. So that would actually be 3 plus 1, which is 4. That'd be 2 minus 5, which is negative 3. So there's the component form of vector A. And now we got to do the same thing with vector B. Now this is the initial point, so that's x1, y1. Terminal point, x2, y2. Put it in here again, and here we go. X sub 2 is negative 4 minus x sub 1, and then y sub 2 minus y sub 1. So it'll be negative 4, 2 plus 5, which is 7. And it doesn't say anything else. It doesn't say find the magnitude or anything like that, or the direction, so we can be done. Okay, number 35, little bit of a different delivery here. It's kind of interesting. Got to give a shout out to Kate the Great. She had an idea for this problem, and I thought it was brilliant. But let me show you something, and then we'll move forward. Use the diagram at the right to determine the component form of each vector below. So ray k, it's right here, plus, I said ray, I meant vector, vector k plus vector m. So we're talking about these two. We're adding these together. Now if we take a look at vector k, we can see this is the initial point right here, and that's the terminal point. So to calculate the x value, we just count, but we also keep track of our direction. So we're going to move right 1, 2, 3, 4, 5, 6. So that right there, the x component is 6, and then the y component is 1, 2, 3, 4. And that's up. Now give me 2 seconds. Okay, continuing on, we're going to add that to vector m. Now if we just focus on this vector m, we're going to realize this is our initial point, this is our terminal point. So to get from here to here, x, we'd have to go left 1. So there's the x component. And then we'd have to go down 1, 2, 3, 4. So that would be the y component. Now, I'm showing you kind of a shortcut method. I'm going to show you what Kate the Great did here in a second. So now we just add individual parts. 6 plus negative 4 is 5. And 4 plus negative 4 is 0. Now, little something something Kate the Great showed is she established that as kind of the origin. And I thought this was great because what she did is she said, I'm going to figure out that as a point, and that's 1, 8. So that point right there is 1, 8. This point right here, if you count it, is 1, 2, 3, 4, 5, 6, 7, and then 12. So that's 7, 12. And if this is the actual origin, or thought to be the origin, and we use this formula up here, this is x sub 2, 7 minus 1 would be 6. And then y sub 2 minus y sub 1 is 8, which is 4. So notice how using this formula, assuming this is the origin, takes care of it in component form. So what I was showing you was this in a way, is kind of like its own origin if you use my technique. And so the x value was 6, the y value was 4, so it kind of takes care of that for you, as if these are 3 different universes, and that's an origin, that's an origin, and that's an origin, if you want to think of it that way. But Kate the Great, that was brilliant. And then just to show you that it works over here, if we figure out what this point is, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that point right there is 9. And then up 1, 2, 3, 4, 5, 6, 7, 8. So that's x1, y1. Those are our initial points. And then this is our terminal. So 1, well, that'd be 8 because it's 1 less. And then 1, 2, 3, 4. Whoopsie. And there's x2, y2. And so if we followed this formula, x of 2 minus x of 1, 8 minus 9 gives us our negative 1. 4 minus 8 gives us our negative 4. So rather than going through this, but Kate the Great, it was brilliant. You can just use the shortcut, establish this as your origin, and then just count. Left 1, down 4. It's a shortcut. So there you go. And there's our answer for letter A. So we're going to stick with the shortcut method from here on in. So we got 2 times vector m. Vector m is negative 1, negative 4. So that's 2 times negative 1, negative 4. The fancy term for this is scalar multiplication. But all you're doing is just doubling the power of the vector, which is just like the distribution property. So you're just multiplying. And then minus vector L. Well, again, this is our starting point. And so that we're moving to the right. 1, 2, 3, 4, 5. And we're not going up or down. So that would be 0. And so then we get negative 2 minus 5, which would be negative 7, and then negative 8 minus 0, which is negative 8. All right, negative 3 times k. Well, we already established k is 6, 4, so it's negative 3 times 6, 4. Just distribute. Negative 18, negative 12. And there's the component form. L, which we've already said is 5, 0, plus 4 times m, and m is here, so I'm going to stick a 4 there, and then distribute it, so I get negative 4 minus 16, distribute, and then add, so 1, negative 16, and there's that. 36. Find the components of the vectors with the given magnitude and direction. So they're telling you the length of the spinner, and they're telling you how far to spin the spinner. So if we just follow the instructions in a grand finale of Rod Stewart, we have a spinner, length 10, that's what this means, magnitude, which means length. So I'm going to make that 10. Spin at 225, that means up. Don't forget that. There's 180. And I got to go 45 degrees more, and my spinner is 10. So the components would be my x value here, and then my y value here. So there's my x, there's my y. This is negative, that's negative. We just need to find it. Well, this is a classic 45, 45, 90. In your world of 45, 45, 90s, you guys are used to x, x, then x squared root of 2, so we multiply this by the square root of 2 to get here. That means we have to divide by the square root of 2 to get back. So we take that hypotenuse, divide by the square root of 2, we should get that square root out of there, and so we would get 5 square root of 2, and that's our left, so that would be negative 5 square root of 2. This is 45, 45, so it has to be the same. And there's the component form. Left 5 square root of 2, down 5 square root of 2. Let's try it with this one. Every picture tells a story, grand finale. So the length of your spinner is 6. Spin at 330, which means 270 plus 60. Means we got 30 degrees left. The more accurate you draw your drawings, I think the better it's going to help your brain. And you have to be careful here. That spinner spun around, and now this is 6. I'm not saying this is 6. That was my original length of my spinner. I probably shouldn't have made my spinner anyways. So got a little confusing there, but there's my spinner, and I spun that spinner all the way around. Now I create my triangle here, and if this is my hypotenuse, which it is, and it's 6, I take half to get here, which is 3, but don't forget the negative, and because it's a 30, 60, 90, multiply that by the square root of 3, and I get 3 square root of 3, and that's not negative because you're going to the right. So my component is 3 square root of 3, negative 3. And that does it.